Assalamualaikum. My name is Farah Shakira binti Muhammad Haris, and my matrix number is AF220004. And today I will be explaining on case study 1, which is a case study on pilot project at Teluk Kalong, Kemaman, Terengganu regarding geotextile tube installation in coastal engineering construction. So the area of study we have chosen is Teluk Kalong, residing in the district of Kemaman in Terengganu, Malaysia. As Teluk Kalong has encountered erosion of the shoreline, hence a pilot project at Teluk Kalong Kemaman, Terengganu is held. The primary objective of this case study is, first, to use geotextile tubes as a submerged dike for coastal erosion protection and beach enhancement along the coast of Teluk Kalong. And secondly, to evaluate how the implementation of pilot project and geotextile tubes aids in the innovation and sustainability for coastal protection measures. Next, the installation of these tubes has provided an effective solution, such as to address the severe erosion and instability of the existing seawall. Next, the geotextile tubes offer a durable and environmentally friendly alternative to traditional coastal protection methods, and it also helps stabilize the shoreline, protect the beachfront, create a more conducive environment for recreational activities, and lastly, a positive visual impact, seamlessly blending with the natural surroundings while providing effective erosion protection. As a result, the use of geotextile tubes as a submerged dike for coastal erosion protection and beach enhancement along the coast of Teluk Kalong has demonstrated significant positive impacts. The installation of these high-strength woven polypropylene structures have effectively stabilized the shoreline, protected the beachfront, and provided a sustainable solution for mitigating severe erosion. The successful implementation of the pilot project has showcased the potential of geotextile tubes as a viable and environmentally friendly alternative for coastal protection measures. While the use of geotextile tubes has proven to be effective, it is important to consider potential limitations and address environmental concerns to ensure the long-term sustainability of coastal erosion protection initiative. Through continued research, innovation, and responsible management practices, the field of coastal engineering can further advance and develop sustainable solutions for shoreline protection and beach enhancement in the future. So what I have learned from this project is that geotextile is a permeable material made out of fiber and used in soil according to ASTM 1994. And there are certain requirements that are needed to be met in geotextile, such as allowing the exchange of substances between air and soil, and that geotextile are manufactured in three different categories, which are textiles, nonwoven, and knits, which are often used to reinforce roads, embankments, ponds, pipelines, and similar applications based on their requirement. Um, and that there are various functions of geotextile, such as separation and filtration, also for drainage improvement, reinforcement, and erosion control. So for my part, it is more to erosion control and for beach enhancement. In summary, geotextile provide a versatile and effective ways to cope with a range of challenges in geotechnical engineering and construction. Um, Lastly, I think I learned a lot from this project, and it has opened my vision to geotextile in construction and geotechnics in engineering construction. Um, this project was a bit tough because of um, mm, the effectiveness of my team members, but I'm glad that they, in the end, gave cooperation to me and to the group workshop. Yes, that is all from me. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif. Now, I want to share about what I learned from the geotextile study. To sum up, especially in the area of geotechnical engineering, geotextiles are essential for improving the stability, durability, and sustainability of civil engineering projects. This study highlights the advantages of geotextile materials in resolving geotechnical issues by eliminating the numerous strategies and tactics used to maximize their performance. It well known that geotextiles are extremely durable synthetic fabric that may enhance soil quality, stop erosion and reinforce building. These studies go which include evaluating the geotechnical applications that are now in use, identifying benefication method, and investigating future research and innovation will effectively met. The given case study further demonstrate the usefulness of geotextile in tackling particular issues like soil stabilization and coastal erosion. The case studies of Tanjung PI, Sungai Haji Dorani and Teluk Kalong show how geotextile system may be successful used in coastal engineering construction. Geotextile tubes are useful for minimizing erosion, protecting natural ecosystem, and advancing sustainable coastal protection measures. They are used as submerged dikes, breakwater, and for accumulating sediment. Geotextiles are useful in many civil engineering applications because they provide erosion control, drainage improvement, separation and filtration, and reinforcing in the larger context. Their application in the building of roads, embankments, ponds, pipelines, and other infrastructure projects enhance overall cost effectiveness, durability, and structural performance. In summary, overcoming obstacles and guaranteeing long-term stability, in-depth knowledge of and efficient use of geotextile are critical to sustainability and success of geotechnical engineering projects. In the toolbox of civil engineers, geotextile proved to be a flexible and essential resource that is essential to the advancement of geotechnical engineering. Thank you.
The loss of mangrove takes an attention of the authorities of Sungai Haji Dorani Selangor. The issue of coastal erosion was exacerbated by the removal of mangrove from the shoreline, which exposed the muddy beach to direct wave. So, the objective of the case study is to integrate approach of mangrove restoration with the use of geotextile tube in order to protect mangrove forests. Other than that, the coastal management project was to promote sediment accumulation and dissipate erosion wave energy. By reducing the wave energy will give an impact to the shoreline and encouraging sediment deposition for mangrove where the main point of the objective for geotextile tube. Sungai Haji Durani needed to service erosion by using geotextile tube. So I will talk a little bit about a case study 3. Sungai Haji Durani Coastal Project promotes sediment accumulation and offers short-term coastal protection. The shoreline was established by sediment deposition that offer a good place to establish mangrove. However, shop item and neighboring homeowner vandalism caused some damage to the geotextile tube in Sungai Haji Dorani and filling materials spilled out of damaged tube. As a result, geotextile tube will perform less effectively in removing wave force and accumulating sediment. The future insight gained from this project is that the planting of mangrove saline must be done at the right time to guarantee the regeneration goal is achieved. So I can tell that our program will function a little bit well because we do it together to do this project. So I will say good job to my team members, and also sir because help us to doing this project and review our last draft. Thank you. Hello, my name is Putri Akila binti Mekasam Sudin with metric number AF220047. Okay, from this project, I was doing case study, application, and also a conclusion for our report. I was doing a case study for number 3, which is a case study for geotextile tube in Nudi course at Sungai Haji Dorani, Selangor. So I will talk a little bit about a case study 3. Sungai Haji Dorani Coastal Project promotes sediment accumulation and offers short-term coastal protection. The shoreline was established by sediment deposition that offer a good place to establish mangrove. However, shop item and neighboring homeowner vandalism caused some damage to the geotextile tube in Sungai Haji Dorani and filling material spilled out of damaged tube. As a result, geotextile tube will perform less effectively in removing wave force and accumulating sediment. The future insight gained from this project is that the planting of mangrove saline must be done at the right time to guarantee the regeneration goal is achieved.
Glima anak Peter AF220038. Today I'm going to discuss a little bit about Geotechnics course, which is BFC 21702. Personally, from my own perspective, from the academic value, Geotechnic is very necessary for civil engineering to equip as a knowledge prior to their career development. But throughout the studies that I've been struggles throughout this second year, is quite difficult for me because there are so many major and minor subject that need to be scored on, and as well as some curricular study that I need to attend. So it's quite really tough for me to catch on everything, but with the assist of Prof. Adnan, really help through the understanding the value of the subject, as well as really develop the passion to it. So I think that when it comes to my own personal experience, I will never felt some sort of stress to study this subject, because it takes time to really blossom the passion into your personal academic journey, as well as things to be thoughtful about this particular subject, because I'm going to continue on Geotechnic 2 and the rest of the Geotechnic course. Objective here are to really utilizing the conventional dewatering technique and mechanical dewatering, on which that this is really important to really manage the coastal. And the second thing, for the geotextile structure, it really helps to reduce the foul smells or attract airborne factor to that particular coastal, on which it may cause to the harm to the ecosystem as well as human being. And for the geotextile containment solution, there are 4 main standard separate part to evaluate the performance of geotextile. First thing first, we're going to look through the target slurry volume based on the given slurry volume, resulting in significant in solid percentage and concentration. Second is the tube success depends on completing the dewatering process within the project timeline. And the third is to maintain the project activeness. Any solid lost through this tube must be corrected quickly. And last not least, to be released back to the environment without further treatment, on which the discharge must meet the specific level as well as represent the maximum concentration or containment in the tube. So the various tests to develop for the on-site during the dewatering station is hanging back test, ASTM D7701, and geotextile tube dewatering test based on hanging back test, whereby the geotextile tube was with a diameter 3.5 was installed at Teluk Kalong, located 150 offshore. It stretches along 500 meter in length, whereby it made from polypropylene geotextile with an ultimate strength 150 kilonewton per meter, and the outer layer are consisted with non-woven polypropylene with the ultimate tensile strength is 40 kilometer, whereby this thing help to stabilizing the structure as well as improve the abrasion and UV degradation resistant. And this tube also filled with slurry to a height of 2 meter and placed to scour apron to prevent scouring around them. So geotextile tube was submerged dikes with 1 meter freeboard during the low tide, and the geotextile tube are going to submerge during the current and wind have a little effect on the performance. The efficiency can be looked through based on the post-construction bathymetry survey was conducted, on which to those which comparing the conducted on the 2 moon season in 2007 and 2008, on which the result have post into the pre-construction survey. And the second thing is you can see the average thickness of sediment is 1.8, then the sediment accumulation is 370 meter cubic, on which I produce a gentler beach profile with a remedial project that start on the Teluk Kalong seashore. And the beach restoration also reduce the depth of water level of the geotextile tube, thereby reducing the impact by approaching the wave fronts or wave forces on the beach and lowering the dynamic energy contributed directly to the beach structure.